Good morning, everybody. Welcome to the 21st edition of the group exhibit, Hydrogen Fuel Cells and Batteries. I invite you to come and have a seat. Drinks are on the house. Perfect opportunity to discuss about some activities in Finland this morning. We shall be discussing fuel cell activities in Finland and the Convion SOFC product. Please help me welcome from Convion the co-founder, Mr. Tuomas Hakala, as well as the development manager at Elcogen, Mr. Matti Noponen. Thank you for joining us.
Thank you.
We're pleased to have you with us this morning. 2 years ago, Mr. Hakala, you made an announcement here at the fair. Can you refresh our memory, please?
You're correct. 2 years ago, we were happy to announce that we had reassembled ourselves to a new startup company. The core team of the company used to be part of Wärtsilä, and we were an R&D division at the time. But Wärtsilä made a strategic shift of activities and decided to seek a continuation for these activities outside of the company. And we were able to start a new company, got some VC funding for it, and Wärtsilä remains a minority shareholder. Since then we've been active in operative work independently.
So this is how Convion was created. 2 years ago, you made this announcement. Now, 2 years later, 2015, what could we announce?
Yeah, we're happy to tell that we've been very busy reimagining our first product, which is a 50 kilowatt SOFC system, a miniature power plant, and we redesigned it and manufactured the first unit, which is, we reached this milestone in February
of this year?
Of this year, and we're able to push the button, and it's been operational ever since, and we're quite happy with the performance and results.
So you just basically finished the design and development of this 50 kilowatt SOFC product. But when I look at your brochure, it says up to 300 kilowatt.
Correct. Yeah. Our intention is to provide systems for this power range of approximately from 50 to some hundreds. 300 is not a fixed upper limit, but it's an approximate range, and we believe that by the modular structure of these installations, you can first of all get the volumes up for these units, but also reach internal redundancy. You can maintain one unit at a time and not stop the entire plant.
So the whole idea is if one was in maintenance, there's probably some maintenance required. You have this redundancy by having it in modular of 50 kilowatt or so.
Yeah, the reliability or security of supply of power is a very important value aspect for our customers. And since in solid oxide fuel cell systems, efficiency, which is another important point, is not dependent on the scale. We can have smaller units and still keep the very high efficiency, and therefore the modular structure, there's no point in building it as a monolithic single plant, but with the flexibility of the modular structure, we can serve customers with different requirements or requirements that grow over years. You can add new modules.
So before I focus on the efficiency of your SOFC product, I want to remind everybody this is a public forum, so you're more than welcome to ask questions. Just raise your hand and I'll come down with a microphone. So you were talking about an efficient product. What kind of efficiency are we looking at for your 50 kilowatt unit?
Currently, our system, we've calculated, should be above 53 electrical net AC. And the fairly high, above 50% efficiency can be maintained from the nominal point down to about 50% partial load. We also see that in the near future it's reasonable to expect to be able to reach a level of 60% by fairly well-known and established ways.
So, and this product runs on natural gas, but I think it'd be important to mention that you've done a lot of design or attention to details to try to have other type of fuels.
Yeah, that's true. We during the years at Wärtsilä, we had quite intensive activities around biogases, and while operating with sometimes very poor gas, we learned a lot and were able to develop the control systems for our system to a level that we are comfortable with running it with gases with variable composition. Also, in the process side, we've done a lot of work on reducing the kinds of components or solutions that would be specific to a fuel composition, and therefore the same design can be used for biogases, fairly good, like digester quality biogas, which is from say 60% methane and above, to natural gas, and therefore the idea is that the core product remains the same, and it's a building block for different types of installations, whether biogas or natural gas or even dual fuel.
So because you have that flexibility of fuel, what's your target market then?
Well, these are modules for distributed power generation. There is, if you think traditionally, distributed power generation used to be dominated by backup, and nowadays, obviously, because of the rapid growth of solar and wind, there's also other types of distributed power generation. This increased security of supply of energy is obviously a very important aspect. But then another type of reason for distributed generation is a fuel source or energy source that is somehow local, and that's where the biogas is coming into this picture. So the same module can be used for building integrated microgrids, for example, and fueled by natural gas, or on-site power generation units for industries needing security of supply, or in biogas applications where you can not only use the local source of fuel, but also utilize internally the heat available from the hot exhaust.
So I'll want to come back about utilizing the heat of your unit a little bit later, but I'd like to start by moving to Mr. Noponen first, just to give us a bit more of information about Elcogen and the product that you offer.
So Elcogen is a company that offers both solid oxide fuel cell unit cells and stacks. So we sell the unit cells to all stack manufacturers worldwide, and these are in commercial phase at the moment, and our stack products are for stationary power markets, for 1 kilowatt size units, and then also for larger systems.
So if you were to do a sales pitch and tell me what's the biggest or greatest advantage of your fuel cell stack or cell over your competition, what would that be?
That is definitely the lower operating temperature of our technology. We operate our cells and stacks both at between 600 to 700 degrees, and this gives the added value for the both stack manufacturers and system manufacturers to decrease the overall cost level of their products.
So why is there a cost reduction because you're operating at lower temperatures?
This is because we can use then lower grade steels in our stack products, and then for system manufacturers this gives the opportunity to, for example, to decrease the size of the airside recuperator, downsize basically also the materials requirements in their systems, and then also use less heat insulation materials, for example.
So you said you operate around the 600 degrees C.
Yes.
And if we were to benchmark with your greatest competition, how much lower is that?
That is roughly 100 to 200 degrees lower. If we look the biggest competitors at the moment, which are operated at extremely high temperatures compared to ours, it's between 800 or above that.
So it's quite significant, and that's how you have so much more advantages on reducing the cost by having less pure material, things of the sort.
That is correct. Yeah.
And I'd like to also bring up, you opened a new factory.
We opened a new factory to Estonia, where our unit cells are produced. Then we also opened a new pilot factory to Finland, where we are producing our stacks. And both of these were done during the last year.
So if you open a new factory, that means you have business. Where's your main markets?
Our main markets for the unit cells at the moment is roughly 50% in Europe and roughly 50% in Far East markets.
And what was the main goal of opening that second factory? You had too many orders to fulfill?
What we have seen is that our products, they have been ongoing quite long validation process in the markets, and our customers are seeing that the product is working nicely, and then the order sizes are increasing at the moment. So with the unit cells, we have basically passed now the customer evaluation phase and now moving to, let's say, small industrial.
Small batch production.
Yeah, you can say that, yeah.
And both of you kind of mentioned this about the validation of a product. You're both in that phase, Elcogen in the stack development, in your case with the distributed power unit. How many hours do we need to say that a product is validated in this industry anyway?
It depends on the customer, basically. There are some customers that are willing to take the risk. They are seeing the technical advantage of our products. Then there are some other customers that want to see, let's say, at least 1 year full operation with the technology.
So will that be the main focus of Elcogen over the next year?
Definitely. We are entering at the moment to customer evaluations. So we are doing this together with selected customers, and then we are also doing definitely internal R&D efforts on proving that the technology is really as good as we believe it is.
And what about for Convion with your new product? Like you finished design, so that means you're testing now?
Yeah, we're now internally testing the system, and next step is to take the first unit out to field, to a customer site. I think also for systems, there are things that need to be proven to customers and audience at large, but also there, I think it's quite a bit validation or showcasing how the cells operate in an industrially relevant conditions and environment. So it's hard to say an exact number of hours, but we need to take this step by step and gradually create more demonstrations which are representative of actual use cases.
So when we see you next year, what should we expect? How many units as a demonstration, and who will receive those units?
Well, the number of units will still be quite limited, but we are in the process of starting particularly biogas-related demonstration projects, and I'll be able to tell more about the details of installations of our systems in Europe at actual industrial installations. The number will be limited, but the use cases are very sort of representative of quite large and fairly untapped market potential.
Both of your companies have benefited from funding from the EU. Can you qualify, is incentives still required in this industry to get us going?
I would say definitely yes. We are still in a early stage of the whole industries in really early stage in this market. So yes, we need these ones.
Any comment from you, Mr. Hakala?
Clearly the cost of particularly cells, but also systems, is very much volume dependent, and since we need to engage partners throughout the value chain and bring build awareness and trust on this technology and its possibilities. We need to do limited number of demonstrations, and then the cost per unit is still quite high. So it's needed for this early stage, but we believe that there's plenty of potential in the large volume market.
You just mentioned because the low units, the cost is still fairly high. And during your pre-interview yesterday, you mentioned that usually for SMEs, the technology is not the issue. It's often the industrialization portion where we have to manufacture in large quantities, where we don't have that expertise. Would you be ready to say then that maybe we need those manufacturers to come to us to take our knowledge or technology and manufacture it?
Yes. It can't be that a single company changes the world. You need the partnerships. You need the value chain partnerships from supply of components and materials to the distribution, manufacturing, and after sales. That's definitely needed, and a small team with experts, the right people and the right sort of experience might be quite efficient or even ideal place to create breakthrough technologies. But then ramp up to production is obviously where you need the partnerships and trust by a larger group of actors.
What I can say about our company point of view is that our starting point has basically been that we are not only developing technology, but we are trying to develop the technology to be as cost effective as possible. And we have actually started from the manufacturing technologies to actually to make the cells, for example, with existing manufacturing technologies that we know that are good when we are going with the scale up. And the same goes for the stack also. So we have started from the manufacturing technologies and seeing that the product is capable.
That's why your background is more than, at the beginning was more the source of the manufacturing knowledge. Is that what you're saying?
I'm saying that we have taken both. We have taken both the technological side and then the manufacturing side as the single road, combining these roads when we are developing our products.
Because sometimes I wonder if we focus too much on making the fuel cells and the hydrogen sub-products too perfect before releasing it to market. I just think about, if we think about the first fridge or refrigerator, it was far from perfect. It leaked, it made ice everywhere, and your food smelled funny. 50 years down the road, we make amazing appliances. Is this something that we need to kind of copy in the hydrogen fuel cells market and get the product out so we learn from that rather than trying to stay in our lab and making perfect technology?
Yes, definitely. We have to go to the markets, definitely. On the other hand, there is really good products at the moment at the market. We all get electricity to our houses, and this is where we are competing, so we have to be also really good when we go to the markets.
Yeah, but I think it's clear that maybe also this industry started in universities or research labs, and what was necessary was the understanding and the functionality of these systems. But I think
it is complex after all.
In startups, cost awareness is very high, and I think overall the industry is beyond the point of showing that it works. It does work, but now it's got to be made robust enough, simple enough, and more than anything at the correct price. And I think that's where we are.
So would you say, is there competition? The current power grid is too successful? Like we need additional legislation to show that it's not green enough for our own good?
No, I wouldn't say that. Distributed power generation is not going to replace the old power infrastructure. It's going to be an additional way of generating power on site for specific purposes. It's not a solution to everything and everybody, and therefore, well, legislation is one issue, but I think this kind of temporary means, such as subsidies, for bringing this to the level when it does not depend on any extra governmental support. That should be the target for everybody. So it's a temporary situation.
Well, unfortunately, we're running out of time, so I want to thank you all for your time. That was a really good discussion, and I invite everybody, if they have more questions for you, to visit your booth, which is located at C54, which is right behind us. Again, thanks to the audience for your time, as well as both of you. Thank you so much.
Thank you.
Thank you. Well done. And stay right with us. We have more coming up. We shall discuss new HRS and hydrogen production in Finland with representatives from Voikoski. Thank you for your time. See you soon.